Welcome to the 9th lecture in the course Industrial Engineering and Operations Research. So, in the 8th lecture, we discussed about inventory management, and particularly in detail, we studied one model, that is economic order quantity model. How you should order, in how much quantity you should order, so that holding cost as well as setup cost is minimized. That means sum total of holding cost plus setup cost is minimized, that we discussed. So, now we will continue inventory management only. This is part 2 of that inventory management, and for this portion I am recommending one textbook also, although there are many books which will describe inventory management, but one book by Jay Heezer et al. Can be taken. It is published by Pearson India Education Services, Noida. Now, I am discussing now here quantity discount model. Sometimes we give discount on the purchase. If you purchase more quantities, you will get more discount. So, a quantity discount is a reduced price P for an item when it is purchased in larger quantities. An example can be, suppose initial price is rupees 1000 per unit, but provided you purchase up to 99 quantities. If you purchase more, then some price reduction will be given. Suppose somebody purchases 100 or more units, but less than 1000, less than 1500. So, in that case, price will be only 998, and if he purchases more than 1500, then price will be 996. So, there are two discount prices and one initial price. So, 100 quantity and the 1500 quantity are called price break quantities, because as soon as you purchase 100 quantity, price breaks, okay, from 1000 it breaks to 998. Similarly, if you purchase 1500 units, then from 998 to 996 price will come down. So, that is why these are called price break quantities. So, they represent the first order amount that would lead to a new lower price. So, the objective in inventory models is always to minimize total cost, because the unit cost for the second discount in table is the lowest. Management may be tempted to order 1500 units. People may think, okay, if I purchase 1500 units, then naturally my price will be much lower. It is 996, but it may not be the case, because inventory cost will increase, holding cost will increase. So, placing an order for that quantity even with the greatest discount price may not minimize total inventory cost. This is because holding cost increases. Thus, the major trade-off when considering quantity discounts is between reduced product cost and increased holding cost. So, on one hand, if you purchase more quantity, there is reduction in price. On the other hand, holding cost increases. So, you have to come in between. So, when the cost of the product is included, the total inventory cost can be calculated as follows. Total annual cost will be annual setup, or which we can say ordering cost, plus annual holding cost, plus annual product cost. So, therefore, total cost is equal to D by Q into S, because D is the demand, Q is the quantity ordered. So, D by Q is that number of times I should order. Each time you encounter S amount of money, so D by Q into S plus Q by 2 into IP. Now, here I am telling that Q by 2 is the average inventory, because you order at one go, you order Q quantity, and IP is the holding cost per unit per year, and it is expressed as a fraction of price. So, therefore, total holding cost is I into P, plus you get P into D also. P is the price and D is the demand. So, this is the equation. Now, what you do here, that now here the holding cost is IP instead of H, as seen in the regular EOQ model, the price of the item is a factor in annual holding cost, unlike a constant holding cost. So, the price per unit changes for each quantity discount. Thus, it is common to express the holding cost as a fraction I of unit price P when evaluating costs of quantity discount schedule. Now, for the discount problem, EOQ formula can be modified now. Q star is equal to under root ds by IP. You can derive this and you can see. If you differentiate this with respect to Q, then Q term is here, Q term is not here in PD. So, therefore, that will not come into picture, and ultimately you will get the same type of formula. Instead of H, it will be IP. So, Q star will be under root 2 ds by IP. This is economic order quantity. Now, let us do it example, run through the example. Annual demand is 5200 and the order cost is rupees 2000. Demand is 5200. S setup cost is rupees 2000 and I is equal to 0.28. That means this is the holding cost expressed in the fraction of the item cost. Okay, suppose item is of 1 rupee, then you have to pay 28 paisa in holding. Now, EOQ for rupees 996, suppose I have ordered maximum quantity, so I will get full discount. So, for 996 EOQ then comes out to be Q star is equal to, you put these values under root 2 into demand 5200 into S 2000 divided by 0.28, that is a fraction of this one, 0.28 into 996. So, that becomes the total holding cost per unit per year, and then it becomes a 274. So, this is basically annual holding cost. 0.28 into 996 is annual holding cost, just as you used to say that annual holding cost. So, this becomes is equal to, basically comes out to be 274 units. But as 274 units is less than 1500, you have to, for taking the discount, you have to order 1500 quantities, but this value is coming 274 only. So, the price break quantity needed to receive the rupees 996 price. Therefore, the EOQ for the rupees 996 price is not feasible. So, this is not a feasible amount. Then what to do that actually? Then what we do that? Now, suppose I go to second discount price. Now, again you take the same data, D is equal to 5200 demand, S is equal to rupees 2000 per order and I is equal to 28%. Now, EOQ for rupees 998 will come out to be 273 units. So, this amount is feasible, because if 273 units were actually ordered, the firm would receive rupees 998 purchase price. So, therefore, you have to see that to what steps we follow and how we take decision, we will discuss that. So, steps followed in quantity discount model are as follows. For each discount, calculate Q star. If Q star for a particular discount does not qualify, choose the smallest possible order size, that means adjusted Q star to avail the discount. You can adjust little bit, and for each Q star and adjusted value, calculate the total cost. Based on the lowest total cost, make the decision whether to go for that one or not. So, I am giving the example. Let us do that type of thing. Example 1, suppose D is equal to 5200, S is equal to rupees 2000, I is equal to 28%. Now, the quantity discount schedule is given in the table. Okay, that is the same time. This time base price is rupees 1000 only, but discount I have given 960 here, first discount, other discount is 950. Some data just for the change, some values have been given different way. Now, quantity is ordered. So, this is one, if I order between 1 to 999. Okay. So, now the price per unit will be 1000 and then EOQ comes out to be 273. Okay. So naturally that there is no need to adjust EOQ, 273 I will be order, but annual setup cost will be, in that case we calculated this will be 38,095. Similarly, annual holding cost has been calculated, annual product cost is also calculated, and then total cost is the sum of all these things. So it is coming out to be this much quantity. Okay, it is 52,76,315 like that. If I order between 1000 to 1499 and the price per unit is this much, then EOQ here comes 279. Naturally it is not in the range, but I can still consider that okay, instead of 279 I will order 1000, so that at least I can get discount, and with that amount I find out that what is my total cost. So this comes out to be something like 51,36,800, and then I consider the another slab 1500 and above. Here EOQ comes out to be 280. Obviously 280 quantity if I order, then I will not be getting discount. So I have to order minimum 1500, and with this minimum amount I calculate the annual setup cost, annual holding cost, annual product cost, and I sum them. I got something 51,46,433 like that. So we have got for 3 slabs we have got the total cost. Out of that we find that in this slab 1000 to 499 I am getting the minimum cost. So the quantity and price that yields the lowest total cost is 1000 quantities at rupees 960 per unit. That means it is better that I should take a discount. Okay. But of course economic order quantity wise I cannot take, because if I take 279 unit, then naturally I will not get discount. So better to take discount at 1000 and say that yes, it is okay. Now let us see the example 2. In example 2, now if I have got same type of thing, but the prices I have changed a bit. Discount price from 1000 to 499 is 950 only, but here discount price 2 I have made 940. In the previous case discount price 2 was 950. So I just changed that thing and I did the same type of calculation. Quantity if I order between 1 to 999, I get by formula I get EOQ is equal to 273, and it's okay, it is in the range. Total price comes out to be like this, total cost comes like this, and then 1000 to 499, then I get EOQ as 280, but if I order at 280 I will not be getting discount, so I order at minimum possible value, that means 1000, okay, because from 1000 the price break starts, and then I will be getting it at the price of 50,83,400, means 50,83,400, and if I order at 1500 and above, then I will be getting total price as because economic order quantity is 282, but EOQ adjusted is 1500. So total price comes out to be 50,92,000 something. So quantity and price that yields the lowest total cost is again 1000 quantities at rupees 950 per unit. If I changed a bit problem more, that means in this case discount price was say somewhat more low, it was 900 only. Discount price one was the same, but this was 900. Then I do the same type of calculation. I make the table. Quantity I ordered 1 to 99, then economic order quantity was 273, and then the total cost was 552 lakh something. But if I want to take discount of price 1, so in that case economic order quantity comes out to be 280, but I cannot do that, so I have to order minimum 1000, and then like that I do the calculation, then I got 50,83,400. Now in the third slab, if I order 1500 and above, in that range I get economic order is equal to 288, but 288 is not possible for me, then I will not get discount too. So therefore I adjust it to 1500, that is minimum possible thing, and then I calculate everything, that what is the setup cost, what is holding cost, and what is the product cost. Then this I get as 4875933.33. So quantity and price that yields the lowest total cost this time is 1500 quantities at rupees 900 per unit. So this type of thing can be done. And let us say if I take one more example, example 4, here I give basically discount 3, in fact 3 discount prices, 1 initial price. So total 4 price slabs are there. So initial price is 1299 and it is price per unit is rupees 1000. Discount price is 1 and this is 1000 to 4999, so rupees 990, and discount price 2 is 1500 to 9999, rupees 970. Discount price 3 is 2000 and above it is rupees 940. So again I make the table like that. Suppose quantity I order between 1 to 99, economic order quantity will come 273, but corresponding total cost comes out to be 52,76,315. And similarly in 1000 to 499 slab I will get some discount, but economic order quantity comes 274, so I have to order 1000 minimum, and then I get this much cost, that is 52,97,000. and if I take the discount price 2, that is 1500 to 1999, then my price per unit will be 970 and economic order quantity will be 277, and here my total, but I have to order minimum 1500 and based on that total cost is 52,54,633, and if I order 2000 and above, then I will get huge discount. Price per unit will be 940, economic order quantity comes 282 and economic order quantity adjusted is 2000, means minimum 2000 you have to order so as to avail the price discount. Then it becomes a annual setup cost is 5200, annual holding cost is this much, annual production cost is this much, and total cost comes out to be 51,56,400. So the quantity and price that yields the lowest total cost is 2000 quantities at rupees 940 per unit. Now sometimes we have to make use of probability also, because demand etc. may be uncertain. So we make the probabilistic models and safety stock. Earlier we discussed only deterministic problem, now probabilistic model. A probabilistic, also called statistical model, is applicable when product demand or any other variable is not known but can be specified by means of a probability distribution. Probabilistic models are a real world adjustment because demand and lead time won't always be known and constant. An important concern of management is maintaining an adequate service level in the face of uncertain demand. What is service level? Service level is the complement of the probability of stock out. Suppose the probability that I will be out of stock is 0.7, then service level is 0.3 only. If the probability of a stock out or out of stock situation is 0.05, means 5% chances are there that you will be out of stock, then the service level is 95%, or in terms of the probability 0.95. Uncertain demand raises the possibility of stock out. So one method of reducing stock outs is to hold extra units in the inventory. As mentioned earlier, such inventory is referred to as safety stock. Safety stock involves adding a number of units as a buffer to the reorder point. So as mentioned earlier, reorder point is given by, that means at what point I should order, expected demand during lead time plus safety stock. So the amount of safety stock maintained depends on the cost of incurring a stock out and the cost of holding the extra inventory. Annual stock out cost is computed as, annual stock out cost is the sum of the units served for each demand level into the probability of that demand level multiplied by the stock out cost per unit into the number of orders per year. So, we can understand this with an example. Suppose an optician has determined that its reorder point for eyeglass frames is 50 units. Now, its carrying cost per frame per year is rupees 50. Carrying cost means inventory holding cost, and stock out or out of stock or lost sale cost is rupees 400 per frame. That means he would have got a profit of 400, but he is missing that. So, the store has experienced the following probability distribution for inventory demand during the lead time, that means during the reorder period, and this is what number of units. Demand may be 30, probability is 0.3, demand may be 40, it is 0.2, demand may be 50, this is reorder points also, and this is 0.3, demand may be 60, that probability is 0.2, demand may be 70, that probability is 0.1. Now, the store has experienced the following probability distribution for inventory demand during the lead time, means reorder period. The optimum number of orders per year is 6. Okay, suppose that is optimum number of orders, 6 times you can order. How much safety stock should the opticians keep on hand? So, the solution is that objective is to find the amount of safety stock that minimizes the sum of the additional inventory holding cost and stock out cost. So, additional holding cost is equal to holding cost into units added to ROP. Okay. So, that means this is extra holding cost. Okay. So, calculations will be done considering zero safety stock. For this safety stock, a shortage of 10 frames will occur if demand is 60, and a shortage of 20 frames will occur if the demand is 70. Then the stock out cost for zero safety stock is that stock out cost will be what? 10 into 0.2 into 400 into 6. Okay. And then plus 20 into 0.1, that means 20 frames, that probability 20 means cost will come because ROP was 50, but you know that I got a demand of 70, okay, in that period. So, 20 into 0.1 into 400 into 6. So, this comes out to be 9600. So, we can make a table. Safety stock means 0, additional holding cost is 0, but stock out cost will be this much, rupees 9600. Similarly, we can keep a safety stock 10. Then naturally additional holding cost comes 50 into 10, rupees 500, but then that situation will come only stock out will be coming only if demand is more than something 10. Okay. So, that is why that demand is more than 60, then that is why we have to see this one, number of units 70 and stock probability is 0.1. So, 10 into 0.1 into 400 into 6 and is equal to rupees 2400. So, if you add them total cost is 2900. And if I take safety stock as 20, then I am totally safe. Only thing that I have to pay additional holding cost, but safety stock is 20, reorder point is anyway 50. So, 50 plus 20 will be 70 and maximum demand can be 70, because that probability table is showing you that maximum demand can be 70. So, there is no problem and you get stock out cost 0, and therefore, if you sum it becomes 1000. So, the safety stock with the lowest total cost is 20 frames. Therefore, this safety stock changes the reorder point to 50 plus 20, 70 frames. So, that means the safe strategy is that keep the 20 frames as a safety. Then there are some situations like single period models are there. A single period inventory model describes a situation in which one order is placed for a product. At the end of the sale period, any remaining product has little or no value. Examples are seasonal goods which you cannot store, bakery goods. They come and if they are not sold, they are basically useless, newspapers and magazines. In other words, even though items are ordered weekly or daily, they cannot be held over and used as inventory in the next sales period. Therefore, the decision is to be made on how much to order at the beginning of the period. Only that decision you have to make. The exact demand for such seasonal products is never known. Hence, a probability distribution related to demand is considered. if normal distribution is assumed and the management stocked and sold an average of 100 Christmas trees each season, then there is a 50% chance that would stock out and a 50% chance that they would have trees left over. So, that is the thing, that because you calculated that average is 100, so it can be this way or that way. So, to determine the optimal stocking policy for trees before the season begins, management need to know the standard deviation and consider two marginal cost. One is the cost of shortage and then cost of overage. That means overage means if it gets destroyed or it becomes useless, then what is the cost. So, CS is called the cost of shortage, or it is due to underestimation. So, this is sales price per unit minus cost per unit. This is considered cost of shortage, means in a way it is a type of loss, that suppose I am purchasing something with in 10 rupees and I am selling in 15 rupees. So, if I am not able to give it as per the demand, then each unit I am losing 5 rupee. Okay. So, that can be considered as a cost. It is not the cost that you have to pay from your pocket, but it is that type of thing that otherwise if it would have been there, then you would have got a profit of 5 rupee, which you are not getting now. So, that is what it is, this one. So, cost of overage, it is due to overestimation. You overestimated that there will be too much sale, but it was not there. Then you have cost per unit minus salvage value per unit if there is any. So, you get C0. So, the service level, the probability of not stocking out should be equal to or more than the ratio CS by CS plus C0. This can be easily proved. But you know, it is based on intuition also you can make out, that means service level or probability should be higher than this. So, the question is that I give that one example. In fact, it is called a famous newspaper problem. So, a newspaper seller sells 125 copies of a newspaper each day. He believes the sale of the newspaper is normally distributed with a standard deviation of 15 papers. He pays rupees 3 for each paper and sells for rupees 5. He is given a rupees 1.5 credit for each unsold paper. So, it is something like salvage value. He wants to determine how many papers he should order each day and the stock out risk for that quantity. So, here you find out cost of shortage, that is sales price per unit minus cost per unit. So, this is rupees 5 minus 3 is equal to rupees 2, because he gets profit of rupees 2 in each paper. And cost of overage means cost per unit is 3 and salvage value per unit is 1.5 only, because if he old papers are sold at 1.5 only. So, rupees 3 minus 1.5, rupees 1.5. So, the service level should be more than this CS divided by CS plus C0, 2 divided by 2 plus 1.5, and this becomes 0.57. Now, the Z value according to normal distribution, we get normal distribution chart is there. In that you get Z value has to be evaluated, that yields a probability of 0.57. So, you can use MS Excel command norms in 0.57 and Z value comes out to be 0.1789. The command norms in P in MS Excel returns the value Z such that with probability P, a standard normal random variable takes on a value that is less than or equal to Z. So, hence optimal stocking level is 125 plus 0.1789 into standard deviation. So, 125 plus 0.1789 into 15, this becomes 128 newspaper. Okay. Now, another situation can be there, fixed period system. In a fixed period system, also called a periodic review or P system, inventory is ordered at the end of a given period. On hand inventory counted at that time, only the amount necessary to bring total inventory up to a pre-specified target level is ordered. So, when the time between orders passes and order is placed to raise the inventory up to the target quantity, the amount ordered during the first period may be Q1, the second period it may be Q2 and so on. The Qn value is the difference between current on hand inventory and the target inventory level. So a fixed period system is appropriate when vendors make routine, that is a fixed time interval visits to customer to take fresh orders, or when purchasers want to combine orders to save ordering and transportation cost. For example, a vending machine, an automatic machine that sells food or other items, company may come to refill machines every Monday. So every Monday it will come and see that what is the inventory level, and whatever is the deficit, that will be ordered. So the disadvantage of fixed period system is that because there is no tally of inventory during the review period, there is the possibility of stock out. This scenario is possible if a large order draws the inventory level down to zero right after an order is placed. Hence, a higher level of safety stock as compared to a fixed quantity system needs to be maintained to provide protection against stock out. Now, let us discuss, that some of the inventory techniques, control techniques. So, inventory control techniques involves monitoring stock usage, movement and storage in a business. It is carried out whether the inventory is located at its warehouse or in different locations. So, we have very popular that called ABC analysis. ABC analysis divides on-hand inventory into three categories on the basis of annual dollar volume. ABC analysis is an inventory application of Pareto principle. Pareto was an economist. He gave a principle. He says 80-20 rule. It states that 80% of outcomes from 20% of causes. So the idea is to establish inventory policies that focus resources on the few critical inventory parts and not the main trivial ones. It is not realistic to monitor inexpensive items with the same intensity as very expensive items. So in the ABC analysis, A class items are expensive, they are high class items with tight controls and small inventories. Such items may represent only about 15% of the total inventory items. They represent 70% to 80% of the total dollar usage, means total annual consumptions. Then B class items are average priced and they may be about 30% of inventory items, but the value wise they are 15% to 25%. And C class are low value, low cost items and they represent only 5% of the total cost, annual dollar volume, but quantity wise they are about 55%. So you should focus more on A class items rather than C class items. That is the way. So benefits of ABC analysis is that increased inventory optimization, improved inventory forecasting, better pricing, informed supplier negotiation, and limitation is there, risk of loss and theft. C class items, because you are not paying much attention, so they may get lost. C class item may have less price but may be crucial, and low information extraction, we may have insufficient data for B and C class. And then similarly there are other type of schemes like ABC. ABC is very popular, but I will just that scan through some other techniques. I will not tell that much detail, but you can make out. HML analysis means we classify high cost items, then medium cost and low cost. ABC also does, but ABC is annual cost basis, but here individually that which item is of high cost. Then VED means vital items, essential items, desirable items. So we may pay more attention to vital items. SDE analysis, scarce items, difficult items, easily available items. And again we may pay more attention to scarce item, medium attention to difficult. Similarly, FSN analysis, FS means fast moving, that means items that are frequently issued, slow moving and non-moving that are not used for more than a particular duration. GOLF analysis, GOLF stands for government controlled, open market, local supplies and foreign market items. So you know that which item, suppose foreign market item is there, then you have to be careful because foreign policy may change. XYZ analysis, X means very little variation, Y means some variation, Z means most variation in the demand. Okay, so it is based on the demand why you classify. SOS analysis, it stands for seasonal items and off seasonal items. Okay, So you can combine various things like ABC with XYZ, ABC with VED, XYZ with FSN, XYZ with VED, like that you can do that. So this much only in this lecture. Remaining things will be telling to you in the remaining lecture. Thank you very much for your attention.